Hello people, welcome to this new video. So in this video, we'll be discussing about the operating modes of the ARM7 processor. Okay, we have studied the concept of underlying architecture of an ARM processor. So this 10 minutes, actually it's quite important. This is a short video which I'll be making of. In this video, we'll be studying how your processor enters into different modes soon after you switch on your system. It might be any system. Okay, so as soon as you switch on your system till you switch off your system, what are all the different types of modes your processor enters? Okay, so you have totally of 7 modes. Okay, first is your user mode, system mode, and you have see all these modes: normal interrupt mode, IRQ, FIQ, abort, okay, undefined. Okay, all these types of modes which you have. We'll start from one by one. Okay, so first I would like to tell you, so as soon as you switch on your system, okay, so when you reset anything, okay, so the program is started. The very first program is your bootstrap program. Okay, when the BIOS runs, okay, so that is the very first program when you start your system, when it runs. Okay, that will be in your supervisor mode. So supervisor mode, we have the mode in which we are not able to access that particular mode. It is completely the supervisory level in which you are not, the user will not be privileged to access that particular mode, in which your system programs will be invoked there. So that is the very first mode. Okay, so soon as your supervisor mode, your system enters to your user mode. So user mode is the mode where 95% of the system where we will be in. Okay, that is where the mode that will be using. Okay, that is called as user mode, where all the normal operations, anything which we want to have, so that is the basic mode. 95 to 99% of the operating system or the processor spends itself is in the user mode. Okay, is the concept clear? So okay, your program is being, or the instruction is being started now. Let's say your instruction is being started. When the instruction is being started, okay, let's say an example, we'll take up example and see. Okay, so your instruction is being started. So during the execution, if it encounters any interrupts, okay, it enters to the IRQ mode. Okay, if it's a normal interrupt, it enters IRQ mode. If it is a fast interrupt, it encounters, or it enters the FIQ mode. Okay, so now we'll take up a small example now. See, I have an application in my mobile phone or anything. Okay. Before that, I want you people to know this concept. It's a small concept. See, your memory consists of programs as well as data. You have user, we have system program, system data, user program, and user data. Okay, we have system program and system data, user program and user data. See, system program can access user program as well as user data. System data can also access this user program or user data. But I think you know this. User program should not access this system program or system data. So for these kinds of things, see, assume that, for example, uh, if you click on WhatsApp application, if anybody else who can access your files which has been placed inside your WhatsApp application, if he or she is able to access your data from there, it is somewhat like user program is acting on your system's data, which is the data which is present inside your phone. Okay, it should not happen. So this is where your, see, like Intel and big companies like IBM, okay, all those companies, this is where the concept of companies of virus came into existence, and those people started working on a security that has to be provided for your system program and the system data. A security has to be provided. So why? Because your user program should not access the system programs or the system data. See, it's very simple. Taking much example, I'd like to take up one example. See, I'll send you a WhatsApp message. In that message, I'll send you a code. The code consists of an addition of two numbers, and I'll tell you, see, people, you just open the code and you start executing that particular code, and in that particular code I'll put another function which start running itself, so that it takes few data from your phone and sends me that particular data. So where your, see, a program which a small code snippet which I have sent to you people is addition of two numbers. So in that particular addition, in that particular program, I have embedded another small function. What is the job of that function? It tries to invoke whatever the data which is actually present inside your system, which I want to access there. So at that point of view, your user program is actually trying to access your system program or system data. So this is the point where the engineer started thinking like this should not happen. Okay, so an privilege has to be set. Okay, so that privilege is being given for this system program and system data, which we call it as a supervisory privilege or the supervisory mode. Okay, to which we are not able to, we should not be able to access that particular data. Okay, if you are able, if your program or data tries to access this system program, your processor shift itself from user mode to abort mode, where your application is being killed, where your application will be stopped. Okay, thus that is where your system and your processor enters from your user mode to your abort mode. It gets, your application gets killed, that's it. Okay, see, point is very simple. I have written here, it is prefetch abort and data abort. See, it's very simple. If your program, user program, starts accessing your system program, it is called as prefetch abort. Okay, so if your system user program starts to access your system data, we call it as data abort. So prefetch abort, data abort. So next we have, let's consider one scenario. Okay, a beautiful scenario which you would love to listen. Okay, see, we have I said division operation is not possible, okay, in ARM processor or any other function. Okay, see, ARM is somewhat, it's limited, right? I told you that it's very rigid. So the functions which are, all the functions which are there inside the ARM processor are very less, okay, when compared to many other processors. Okay, so if the function is not present in ARM processor, it's the duty of the engineer to create another. We have the concept of coprocessors. So what's the use of coprocessors? A processor which is built perfectly to carry out extra operations which is not there in your ARM processor. Okay, let us say we built a processor to carry out the fraction operation of division operation. So ARM does not perform division operation, so that particular division operation is carried out by your coprocessor. Okay, I'll repeat it. ARM does not perform division operation, so taking that as a disadvantage, I'll build another processor which performs division operation. Now the programmer writes a code to perform some operation which is not present in the particular processor, or assuming that there is some coprocessor which performs some action, the code, the designer writes the code for that which is not there actually. In that particular situation, your processor will be shifted from your user mode to undefined mode. So what do you mean by undefined mode? See, it checks for the things within the processor. If it is not available in the processor, it goes to the coprocessor. If still that program is not visible, it is not defined itself in the coprocessor also, it enters your undefined mode. So this is where it tells that this function is not defined. So if it is not defined, let's say instruction 1 started its execution, instruction 2 is undefined, it won't go to instruction 3, right? Okay, it's very simple. I'll take some amount from somebody else, I want to give it to somebody else. So instruction 1 has given me some data which I have to give it to some other person. I cannot I cannot give money from myself to somebody else, right? So if I get money from somebody else, so that particular money I can get it and give it to somebody else. In the same way, instruction 1 is being executed. If instruction 2 is not executed, I cannot go for the next instruction. Are you people getting it right? Okay, this is where your undefined mode is entered. So apart from that, we have another mode called system mode. Any system call, okay, we have, see, when you study the concept of operating system, we have few concepts like semaphore, mailbox, okay, deadlocks, the concept of deadlocks. See, those are all, see, it's a really beautiful subject, operating system, which I would like to discuss, okay, because in this subject, if I start explaining you the concept of mutex, semaphores, mailbox, okay, and the concept of deadlocks, it takes much time. So those we call collectively as a system call, where these kinds of we really not tell, it's a kind of error, okay. These are called as system calls, okay. Those are all kernel operations, okay. So at that particular time, your user mode enters your system mode, where your kernel level operations are carried out, okay. This is where, if you encounter the concepts like system calls, the user mode is then shifted to kernel mode. So this is how your processor changes itself or adopt itself or migrate itself to different levels within a processor. These are all the operating modes of one's particular processor. So to give a quick overview of the whole concept, I'll repeat it once again. Your system is being started. Where will be your system? It will be in the supervisor mode, okay. That is the very first mode. Then your system enters to your user mode, okay. It starts running the instruction. If it gets a normal interrupt, it enters IRQ. If it gets a fast interrupt, it will get enters into FIQ mode, and then it start if your user program start accessing your system program or system data, it enters to abort mode. If your user program start accessing your system program, we call it as prefetch abort. If it start accessing your data, system data, we call it as data abort. And then if your instruction consists of those instructions which it is not there in your ARM7 processor and also your coprocessor, then your processor enters from your user mode to your undefined mode. And then we have the last mode, where we have system call operations like mutex, deadlocks, semaphores and all. If these kinds of situation occurs, your processor enters from user mode to your system mode. So this is how the different level of operating modes happen in ARM7 processor. Hope so you would find this video helpful when you study the concept of operating modes. Thank you. All the best.